All right, in this video we're going to do a few more examples here of finding Taylor and MacLaurin series. And we're going to start with a couple more MacLaurin series. And our first one is to find the MacLaurin series of f of x equal to sine of x. Okay. Now for this, what do we need to do? Well, we need to recall that our MacLaurin series has this form. It is the series from n equals 0 to infinity of the nth derivative of f evaluated at 0 all over n factorial x to the n. Okay, so let's go ahead and again, let's find our values of the nth derivative of f evaluated at 0. So let's do that. All right. Well, our original function is just f of x is equal to sine of x. Then we have f prime of x is equal to cosine of x. F double prime of x is equal to negative sine of x. F triple prime of x is equal to negative cosine of x. And the fourth derivative of x just goes back to the original function, sine of x. And this will repeat forever. So let's go ahead and evaluate all of those at 0. Well, sine of 0 is 0. F prime of 0 is cosine of 0, which is 1. F double prime of 0 is negative sine of 0, which is 0. F triple prime of 0 is negative cosine of 0, which is negative 1. And the fourth derivative of f at 0 is sine of 0 again, which is 0. Okay. Well, let's put all of that together. So our MacLaurin series for sine of x is the series from n equals 0 to infinity again of the nth derivative of f evaluated at 0. I'm just rewriting this again up here. X to the n, just rewriting that so we can fill this out. Well, let's plug in n equals 0 and what happens? Well, that is f of 0, which is 0. So we get 0 as the first term here, plus, let's go ahead and plug in n equals 1. Well, n equals 1, we get f prime of 0 is 1, so we get 1 over 1 factorial x to the first power. Okay. Plugging in n equals 2, we're going to get 0 again. Plugging in n equals 3, we're going to get negative 1 over 3 factorial times x to the third power. And this pattern repeats. For n equals 4, we get 0. For n equals 5, we get plus 1 over 5 factorial x to the 5th. 6 is 0. 7 is a minus 1 over 7 factorial x to the 7th. And then we continue that forever. Okay, well, let's write out what that is. Well, this is the series from n equals 0 to infinity of, and notice our first term is positive, our second term is negative, our third term is positive, our fourth term is negative. I say all of that skipping the zeros. So really we go positive, negative, positive, negative. So that is an alternating series, negative 1 to the n. What is our exponents? Well, we get x to the, our first exponent is 1. Our second exponent is 3. Our third is 5. And our fourth is 7. So this is the formula 2n plus 1. So we get x to the 2n plus 1. Okay. And what is in the denominator? Well, in the denominator, we get 1 factorial, then 3 factorial, then 5 factorial, then 7 factorial. So that is, in fact, 2n plus 1 factorial. And so our representation, our MacLaurin series representation for sine of x is this series. All right. Well, let's go ahead and do 2 more examples now in this video. And the second example is going to rely very heavily on that first one. Okay. And this is, we're going to find the MacLaurin series for cosine of x. All right, well, for our solution here, we just differentiate the series for sine of x. Because the derivative of sine of x is cosine of x, right? d dx of sine of x is cosine of x. So if we differentiate the power series that represents sine of x, we will get a power series that represents cosine of x. Okay, so differentiate that previous series. You can look back at your notes from what you wrote down from this first example. But when we do that, this gives us that cosine of x is equal to, we just differentiate the first term in our sine of x series. That first term was x, so differentiate that, we get 1. Our second term was negative x cubed over 3 factorial. We differentiate that, and we get a negative x squared over 2 factorial. Our third term was positive x to the 5th over 5 factorial. We differentiate that, and we get x to the 4th over 4 factorial. And we continue on. Our next term is going to be x to the 6th over 6 factorial, and so on. This ends up being the series n equals 0 to infinity, negative 1 to the n. Again, we start positive, then go negative, so this is just negative 1 to the nth power of x to the 2n all over 2n factorial. And we now have our representation for cosine of x. All right. We have one more example that I want to do here. And that is to finally do an example of a Taylor series. So remember, a Taylor series is exactly like a MacLaurin series, but we no longer use a equal to 0. And we're going to find the Taylor series for f of x equal to 1 over x centered at a equals 3. For this, what do we need to do? Well, we need to do the same thing as before. We need to find our derivatives. And we'll do that for a few terms here. Well, our original function is 1 over x. Then our first derivative of that is negative 1 over x squared. Our derivative of that is 2 over x cubed. Then the derivative of that is negative 3 times 2 over x to the 4th. And the derivative of that is positive 4 times 3 times 2 over x to the 5th power. We want to evaluate all of those at a. So let's do that. So we evaluate this at a equal to 3. And what do we end up with? Well, f of 3 is 1 over 3. F prime of 3 is negative 1 over 3 squared. Then f double prime of 3 is positive 2 over 3 cubed. f triple prime evaluated at 3 is negative 3 times 2 over 3 to the fourth. And the fourth derivative of f evaluated at 3 is positive 4 times 3 times 2 all over 3 to the fifth power. Okay. Now, what do we do with all of that? Well, we'll put all of this together. And the nth derivative of f evaluated at 3 is, in fact, negative 1 to the nth power, right? Because we start positive, then we go negative, positive, and then negative, and we're starting at n equals 0. And if we start at n equals 0, this is 1 is 0 factorial. Then n equals 1, well, 1 factorial. N equals 2, we get, 2 factorial. N equals 3, we get 3 factorial. N equals 4, we get 4 factorial. So this is, in fact, just n factorial in the numerator, all divided by 3 raised to the n plus first power. And so this is our function or formula for the nth derivative of f evaluated at 3. So let's go ahead and plug all of this in then. So f of x, which is 1 over x, is given by our series from n equals 0 to infinity of, let's plug this in. So we just write that out, negative 1 to the n factorial over 3 to the n plus 1. But remember, we also divide by n factorial. Excuse me, that's not true. Yeah. So we divide by n factorial there. And we end up with, and we have x minus 3 to the nth power as well. All right. And what do we notice? Well, these n factorials cancel. And so we end up with the series from n equals 0 to infinity of negative 1 to the n all over 3 to the n plus 1 times x minus 3 to the nth power, right? It's x minus a to the nth power. Okay? And recall again, we do get n factorial there in that denominator. That is part of our definition of our Taylor series. So we get that n factorial there. That cancels with our n factorial that was generated from this function, from our derivatives of f evaluated at 3. And we end up with this as our Taylor series for 1 over x centered at x equals 3, or a equals to 3. And that is it for this video.